Is gravity in the universe buggy? What's wrong with tiger stripes and outliers on Enceladus? Has the mystery of the strange cosmic circles been solved? We will talk about all this and much more right now, in the 156th issue of Astrobzer. Well, I'm Andrei, and you're on the Cosmos channel simply. Scientists have found a glitch in gravity. This is the title of a new scientific article, published in the journal Cosmology and Cosmomicrophysics. A cosmic glitch in gravity. What kind of glitch is this? If you run through the annotation with your eyes, then you can also stumble upon the word ether. Some people will be very excited by this word. But let's figure out what the point is here. I think it's no secret to many of you that the most successful and generally accepted modern theory of gravity is Einstein's general theory of relativity. Although I'm almost sure that in the comments to this video, there will be those who want to argue with this. It really won't be scientists. Well, that's fine. For a long time, Newtonian mechanics coped quite well with the description of gravity. In general, it is still quite suitable for many tasks. It works on a terrestrial scale. With the help of its formulas, it is quite possible to launch spacecraft, say, to the moon, and not only to it. But at some point it starts to fail. Probably the most famous indicator of this, which eventually led to a revision of views on gravity, is the problem of precession of Mercury's orbit, or the displacement of the perihelion of Mercury. I have already talked about this, but in short, the bottom line is that the perihelion, or the point closest to the Sun, of Mercury's slightly elongated orbit, is shifting. And the calculations based on Newton's old law of universal gravitation were slightly at odds with real observations of the behavior of the planet. There was clearly some effect here that Newtonian theory did not take into account. But here are calculations based on Einstein's general theory of relativity, which describes space, or even more precisely a single spacetime, as a dynamic entity, capable of bending, and gravity, in fact, as a curvature in this fabric that massive bodies create. These calculations perfectly agreed with observations of the behavior of Mercury in its orbit. It was one of the first, but by no means the only success about that. We have already discussed with you many times various experiments that confirm Einstein's theory, and various successful predictions that it has made and is making. These are black holes, which were first predicted as a solution to Einstein's equation. These are not gravitational waves, which were also predicted and then registered on special detectors. These are the effects of gravitational lensing. Then the curved spacetime distorts the image of distant galaxies, which we literally see with our own eyes in such images. And so on and so on. Well, there are problems about that, of course. For example, we seem to have found black holes, but there are questions about the supposed singularities, the existence of which follows from the Uto. On large cosmological scales, too, not everything is smooth. Here you can recall a couple of famous tensions. First of all, it is, of course, the Hubble tension, the essence of which is that different methods of measuring the rate of expansion of the universe give slightly different results, and it has not yet been possible to solve this problem. And also, for example, the so-called tension with 8. I talked about it in more detail recently, in the 147th Astro review. The problem here is not with the expansion of the universe, but with how matter in the universe gathers into a cluster. On a large scale, here, as in the case of the Hubble tension, the measurement of the early universe and the later one conflict with each other. There may be different reasons for this, for example, problems with measurements. But it may also be that we somehow misunderstand gravity. In general, something is wrong with the general theory of relativity. It's like in certain situations, or on certain scales, Newton's law of universal gravitation stopped working, maybe in a similar way. Again, in certain situations, Einstein's general theory of relativity also stops working. Just such a model was considered in a new article in order to try to solve some inconsistencies of modern theories. Well, what about the mention of ether, which could please some of Einstein's haters? That ether, also known as the luminiferous ether, is a kind of medium, the vibrations of which would be light, or rather electromagnetic radiation. Theories and ethers were popular until the 20th century, but with the advent of the theory of relativity, ether in this form was abandoned. But now the ether is still loved by all sorts of alternative artists, and those who do not like Einstein, and about that, I haven't touched on this topic in detail yet. For example, Pobdinsky had a video about this. But in any case, fans of the ether should not be happy here, because this is not about that. Einstein and ether theories are mentioned here, but this type of theory is not about the same ether. In these theories, a modified general theory of relativity is considered, in which there is a certain preferred frame of reference in the universe. Well, what kind of glitch is this from the title of the article? Here again, scientists have modified Einstein's equation. Namely, we added an additional parameter to it. This parameter, at certain values, works so that gravity will behave a little differently at different scales. Namely, within the framework of this model, on the scales of planetary systems, galaxies and individual clusters of galaxies, everything works as it worked before. But on the scales of many billions of years, comparable to the size of the observable universe, gravity works a little weaker. By the way, if you read some press releases, and not the scientific article itself, you may get the impression that everything is really the same in practice and gravity is weaker on a large scale. But no. It was they who adjusted the parameter in the model so that gravity was a little weaker. Namely, it is about 1% weaker on cosmological scales. And so the authors of the article write that such slightly modified formulas with only one added parameter, to some extent, cope better with group problems, such as Hubble tension, and the problem of accumulation of matter. They do not solve them at all, as again you might think if you read only press releases, but they weaken them to some extent. This additional parameter, which they added, they call the gravity glitch. In the future, this model can be tested, for example, with the help of new cosmological surveys and more detailed maps of relic radiation. Here is a beautiful planetary nebula. But what does the planet have to do with it? So, why is a planetary nebula called a planetary nebula? Planetary nebulae got their name due to their similarity to images of planets, glowing disks, in contrast to images of stars that do not have noticeable sizes. Even then, astronomers understood that despite the external similarity, it was not a planet in front of them, but another object, since, unlike planets, planetary nebulae are motionless in the firmament. Not bad. By the way, Neuro helped me figure out the question. This is a new service, and it is available in the Yandex app with Alice. When you ask a question, the service quickly analyzes all open sources and takes information in one answer. But most importantly, the answer contains all links to information resources. And you can check everything yourself or delve into the topic by following these links. It's also cool that Neuro can ask additional clarifying questions. For example, I asked about the internal structure of black holes and then clarified what alternatives there are to these objects. The service greatly simplifies the search for information. Follow the link in the description and install the Yandex application with Alice. China sent a secret lunar rover to the moon. Let's start the cosmic selection with him. China has launched its next mission to the moon, Tian E6. In previous missions, they have already delivered samples from the moon and landed on its reverse side. But no one has delivered samples from the back of the moon's moon yet. This is exactly the main task of the mission. As is often the case with Chinese space missions, not all the details about them are known. Shortly after the successful launch, the Chinese National Space Administration published new images and snapshots of the device. And people quickly saw this on them. Some kind of small machine with wheels. This is clearly a lunar rover, but nothing has been said about it before. It was also found out that it is equipped with an infrared spectrometer, but its purpose is still unknown. What do you think they will do there with this secret rover? And you know what else will fly to the moon? Nokia. It's a pity that it's not 3310, but by the way it's close. The company is developing the infrastructure of 4G networks for the moon. They won a grant from NASA to develop a communication system for the moon, and instead of inventing everything from scratch, they decided to adapt the existing 4G technologies. The first element of the network should fly to the south pole of the moon this year. And first, it will provide communication between a pair of rovers. This is how they are going to test the performance of the technology. Well, in the future, with the increase of the network, 4G technology can provide higher data transfer rates than the high-frequency communication that is used now. Well, on Mars it will be possible to use a similar system and upgrade to 5G. I wanted to say that on the moon, no one will protest against the 4G towers, but it's interesting that this is not quite true. Radio astronomers are a little concerned here that such a connection will create unnecessary interference in the study of the universe. At least in theory, it is possible to choose frequencies so as not to screw up astronomers too much. Lasers are now being actively used in space. And not like that, but in order to download pictures. Well, of course, in fact, not only pictures, but in general for data transmission. In the future, optical data transmission may replace radio. So far, the technology is only being tested. And there is one such test setup on the Psyche spacecraft, which is flying to study the asteroid of the same name. Recently, a record was set for transmitting data in this way from a distance of 226 million kilometers. During previous tests, from a distance of 31 million kilometers, it was possible to reach a speed of 267 megabits per second. From a distance of 226 million kilometers, the speed is certainly lower, but still quite decent. 25 megabits. This is noticeably faster than conventional radio data transmission. Scientists have tried to solve the mystery of Enceladus tiger stripes. If we conducted a survey among scientists and asked them if you had unlimited funding for one mission, the task of which would be to search for extraterrestrial life in the solar system, where would you send the device? I think among the most popular answers will be Enceladus, a satellite of Saturn, and Europa, a satellite of Jupiter. Of course, you can also include Mars here, but a lot of vehicles have already been sent there. But there is very little data about these two icy moons obtained from a close distance. There are no surface masses at all. In the coming years, we should learn more about Europe, thanks to two missions, Europa Clipper from NASA and JUICE from EC. And yet, in the Jupiter system, Juno is also flying now, and from time to time throws up something interesting. Like this picture, for example. But with no less interesting Enceladus, it's deaf. So far, all that remains for us is the analysis of data collected by the Cassini spacecraft over the years of exploring the Saturn system and computer models. The spacecraft arrived at Saturn in the year 2004, and soon we saw the incredible. These are the emissions of matter from under the surface. The substance turned out to be nothing but water. Well, that is, what we see here in outer space, of course, already consists of ice crystals, but before that, they could have been liquid water. These emissions served as one of the main evidence in favor of the fact that under the icy crust of Enceladus, there may be an ocean of liquid water, so necessary for life. If there are emissions on Europe, they are not so obvious. But Enceladus, thanks to its ice geysers or cryovolcanism, forms an entire ring around Saturn. Here is a cool photo of the ring, and inside of which Enceladus is visible. Let me remind you that the Cassini device flew through the emissions and measured their chemical composition. And besides water, many other substances were found there, including organic matter, as well as carbon and nitrogen. One of the key elements for life. This made Enceladus even more interesting in the context of the search for extraterrestrial life. Interestingly, giant geysers are not beating everywhere on the icy moon. They are concentrated in the southern polar region, and specifically in the so-called tiger stripes. The name is unofficial, but these stripes really look like they were left by the claws of a giant space tiger. The strips are on average more than 100 kilometers long, half a kilometer deep, and 2 kilometers wide. Most likely, these are tectonic cracks in the icy crust of the satellite. By the way, this famous image is not in natural colors, but in conventional ones. The color of the stripes is really different from the surrounding terrain, but probably not so noticeable. Here is an image from the images in the visible range in red, blue, and green filters, which were processed in such a way as to try to reproduce the colors as close as possible to how we would see the insulat with our own eyes. And here we still see the blue color of the stripes, but not so bright. The stripes are also slightly warmer than the rest of the satellite's surface. The difference is not so big, and it's still very cold there, but it is there. Well, as I have already said, water emissions are concentrated near these bands and apparently beat out of them. But with them, not everything is so obvious. First of all, how does water get to the surface from under the surface ocean? The answer to this question is somehow related to how, in general, there can be a whole ocean of liquid water so far from the sun, under the icy crust. Here, just as Jupiter is crushing Europa, so does Saturn and Enceladus. Tidal forces are to blame for everything. Encella, of course, does not move in a perfectly round, slightly elongated elliptical orbit around Saturn. At different points of the orbit, it is at different distances from the planet, and different tidal forces act on it. Somewhere they squeeze it harder, somewhere weaker. This causes friction and heating in the bowels, which may be enough to maintain water in a liquid state. This can also help to break out in the water to the surface. When a satellite is constantly contracting and unclenching, tiger stripes faults in its crust can literally open periodically, giving water from the ocean access to space. And previous models described this opening so that the walls of the fault we opened like elevator doors. But there are some problems with these models. The Cassini spacecraft has observed the ejection from the satellite enough to notice that their behavior changes over time. Ice geysers strike harder, then weaker. These changes are periodic, and one cycle lasts 33 hours. Do you know what else lasts 33 hours? My attempts to defeat the final boss in the axe. That is, it takes exactly 33 hours for Enceladus to make a full circle in orbit around Saturn. It seems to be expected. It is during this cycle that the tidal interaction between the planet and the satellite changes. As you move along the orbit, maximum emission activity should occur at a certain point. But if we look at the curve where the activity is shown, we will see that, first of all, in addition to one of the largest peaks of activity, there is another smaller peak. And secondly, these peaks happen, not, say, during the maximum approach to the planet, but with a delay of several hours. The old model with the opening of cracks cannot explain all this. Well, the authors of the new article, which was published in the magazine Nature Geosciences, we developed models, conducted computer simulations, and maybe everything is arranged a little differently. And tiger stripes behave like a well-known fault on Earth, the San Andreas Fault. This fault is located at the junction of two lithospheric plates, North American and Pacific. A considerable part of it is located on land, and it is perfectly visible in these pictures. As we know, an earthquake often occurs in such areas. But the movement of the plates relative to each other can be different. Not only one fits under the other. There is also a horizontal displacement, like this, and this also leads to earthquakes. And the authors considered exactly such a model, where the fault walls do not just diverge to the sides like elevator doors, but move horizontally parallel to each other. Uneven walls, moving horizontally along the fault, can also create open areas, through which water from under the surface ocean breaks out and hits geysers. Scientists have modeled this option on a computer, and their model coincided well with Cassini's observations, which means it can explain both two peaks of activity and a delay of several hours. Now, of course, we need to confirm this model with the help of new observations. This could be done by a new mission to Saturn and Enceladus. The movement of a section in the surface can be recorded, for example, with the help of radar observations. Similar horizontal shifts on Earth are already being recorded with the help of satellites. And of course, such observations would also give us more useful information about the properties of Enceladus, about the thickness of its crust, about how long the ocean has existed there. And all this will help answer the question of whether it can be habitable. Perhaps scientists have got close to solving the mystery of strange cosmic circles. This, of course, is not about aliens, but about orcs. This is how the objects are called orcs. This is an abbreviation of the English strange radio circles. I talked about them about 4 years ago, when they were just opened. And then scientists, in fact, had no idea what they were. It is not by chance that they were called strange. In general, it's cool when it turns out that I'm telling you about some new discovery in the astroview. But I say that new research will be needed to explain it. Scientists are conducting these studies, new answers are being found, and I'm coming back to you with these answers, even a few years later. I wouldn't say that the riddle has been solved 100%, but now there are already good versions, supported by observations and models. Let's first remember what is so strange about these circles in general. First of all, it's cool that the objects can be said to have been found manually. Now, due to the large amount of data, it often happens that initially the images are viewed by computer algorithms. Scientists found the first 3 orcs simply by visually viewing the data obtained by the MASCAP radio interferometer. Another one of the first 4 such objects was found already in the archival data of the Indian Gyempti Observatory. They look like fairly large objects of round or close round shape. Radio circles, actually, because they are observed in the radio range. But it is strange that then no traces of these circles were found in any other ranges. There is no obvious visible light or infrared radiation there. They also tend to have a brighter ring around the edge. What they were, it was not clear. On the one hand, you never know if there are round objects in space. Yes, almost everything is round there. To one degree or another, they were introduced from one or another angle. This is how a distant galaxy, a planetary nebula, a supernova remnant, and a protoplanetary disk can look like from a certain angle. There are many options. Well, first of all of these objects, as a rule, are observed not only in the radio range. They have a visible X-ray, infrared component, or all at once. And here, initially, only the radio was observed. The options I have listed below, and not only them, which scientists naturally considered, these are all objects of very different scales. Whereas a planetary nebula the size of, well, a few light years. And where is a galaxy that can be tens or hundreds of thousands of light years across? If this is a planetary nebula, or a supernova remnant, and at the same time, we clearly observe them not as points, but as sufficiently extended objects in the sky, then it means they must be somewhere relatively close to us, in our galaxy. Why did scientists decide that these are not stellar remnants? Well, apart from the fact that these circles were not visible in other ranges, which is not typical for a nebula, some of these objects were quite close to each other in the sky. The probability of such a scenario is small. We know with what frequency supernovae flare up in our galaxy, and you can calculate what is the probability of finding one supernova remnant in a certain volume of space. But when there are 2 or 3 of them in the same volume at once, the chances of this are very low. Well, later distance estimates were made, and these objects are clearly not parts of our galaxy. And this means that they are very large. Now the size estimates are such that an entire galaxy, and even a group of galaxies, can fit inside these circles. Galaxies, say spiral, rotated to us by the plane of the disk or elliptical, they are also clearly not, as in the galaxy. Well, as if there are stars, but they can be seen. Immediately, no visible radiation was observed. In general, when the objects were first discovered, it was not that it was clear what they were. And there was not even any one dominant version. Now there are these versions, and not even one. Today I'm going to talk about 2, and they are united by the fact that they are both connected with the interaction of different galaxies with each other. The first version appeared a little earlier. What if they are formed by supernovae? And you're so stop. After all, we have just found out that these are not supernova remnants, because these new objects are huge. But here everything is trickier, and in general the possible chain of events is very interesting. One exploded star, of course, cannot leave such a noticeable bubble the size of tens, or even hundreds of thousands of light years. But what if more than one star exploded? Suppose, in one small volume of space, almost simultaneously on an astronomical scale, of course, a whole bunch of stars exploded at once. With a sufficiently large number of them, they can launch powerful galactic winds and create a shock wave that will diverge in different directions, approximately in the form of a sphere, push matter apart, and, in fact, form such a bubble. This animation shows how this could happen, and how the first open circle of Org 1 could appear. You probably have a fair question. Why should a bunch of stars explode almost simultaneously in one galaxy? Well, if it's a galaxy to sit quietly and do nothing special, then with no. But if we collide with each other 2 or more galaxies, When galaxies collide and merge, the gas in them also interacts, contracts, and this can lead to the formation of new stars. Merging galaxies may experience a burst of star formation. In such galaxies, tens of times more stars are formed in the same period of time than in ordinary galaxies. In general, among the newly formed stars, there will be some massive ones that will die in supernovae, and whose lifetime is short. So it turns out that some time after the merger, a lot more supernovae will flare up in such a galaxy at about the same time than usual. And collectively, they can disperse a powerful shock wave that forms such a strange circle. But the footage is already from a scientific simulation, which also confirmed that such a process is quite possible. Well, recently another scientific article was published, where the authors also tried to explain the nature of strange circles, but here the story is a little different. There were no supernovae. It all started here with observations. I have already said that one of the main oddities of the orcs is that they were observed only in the radio range. But still, the authors of the new article decided to double-check and observe them in the X-ray. More precisely, we stopped at one particular circle. First, the scientists ran through the already available data collected by X-ray surveys and Rosetta. There wasn't a lot of data there. The area of the sky where the selected radio circle was located was observed for only 7 minutes. For deep space, this is a so-so endurance. But still, scientists have found something. It was not one extended source, but rather several separate small X-ray sources coinciding in the sky with this circle. This particular one, by the way, is not very much a circle. He generally has the nickname clover leaf. But the discovery of these small X-ray sources allowed scientists to beat out a bigger team for themselves, and most importantly, to specifically allocate observation time on the Newton X-ray telescope. And not 7 minutes, but 5.5 hours. And that's what the scientists saw. This is an object in the radio range. And this is the same area of the sky in the X-ray. Here we no longer see individual points, but an extended source perfectly coinciding with the radio circle. And this is a composite image of this area of the sky in visible light, in radio and in X-ray. This is the first such observation of a radio circle in X-ray. But we also see that now he is clearly not only a radio circle. What does this tell us? The radiation shows us the distribution of gas in this area, and we can calculate its temperature. It's about 9 million degrees Celsius. Given how the gas is distributed and its temperature, scientists can calculate that such a picture should have arisen when not just two galaxies merged, but two groups of galaxies collided here. When two groups approach, there is more mass in one region of space, which means that the total gravitational attraction increases. The gas in these galaxies may begin to attract to the center of mass. And at the same time, it accelerates and heats up. In other words, the map of gas distribution and temperature tells us about the merger of groups of galaxies. Well, when this happens, and the substance interacts, again, a shock wave can form, which forms those very strange circles. There is, however, one but. Galaxies and groups of galaxies merge everywhere. However, we do not see strange radio circles everywhere. Why do circles form in some cases, but not in others? There is no answer yet. Perhaps it has something to do with the property of matter in these galaxies before the merger. For example, with how active supermassive black holes were at their centers. In general, there is clear progress in the case of strange radio circles. Interesting versions have appeared. But this is clearly not the end of this story. Friends, do not forget that every 2 weeks there are my exclusive releases of the not included ones, which I record especially for those who support me directly on Boost, on Patreon, and on YouTube. They also get additional nice bonuses depending on the level of support. And don't forget to subscribe to my Telegram channel and contact group in order to receive additional space content almost every day. And always stay in touch. Thanks again to everyone. Bye.